Hi everyone, my name is Valotto, and in this video I'm going to walk you through how a decision tree works using a small dataset of student performance. I will explain how the algorithm chooses the best way to split the data in order to make accurate predictions. In our case, whether a student passed an exam based on how many hours they studied and whether they attend class. I'll draw everything out here in this whiteboard using a free form so you can visualize the process step by step, just like in a real presentation. So let's start taking a look to our data set. It includes 5 students. For each student, we know 3 different things. So let's start drawing. 3 columns. Let's classify these students. First for study hours. Then the attendance. And if they passed or not the exam. The first student studied for 2 hours. The second 4, third 6, the fourth 8, and the fifth 10 hours. The attendance of each one for the first is 1, the second 1, the third 0, the fourth 1, and the fifth is 0. And we can check if they pass the exam. The number 1 is 0. The number 2 is 0. 3, 4, and 5th student, all they passed. And our task is to build a decision tree that can predict whether a student will pass the exam based on these features. So, what's a decision tree? A decision tree is a flowchart-like structure. It starts with a root node that asks questions, then branches depending on the answer. Each node splits the data into smaller and more homogeneous groups, and the process continues until we reach left nodes, which give us the prediction. In classification problems like this, the goal is to split the data in a way that separates the classes as cleanly as possible. To decide the best place to split, the algorithm evaluates options using measures like gene impurity or entropy for information gain. But today, I'll focus on the logic instead of the math. We'll do this looking for the future that separates the students who passed for those who didn't. So let's start finding the best split. We'll start by checking the study hours features. Let's try to split at study hours less than 5. If we do that, we get 2 groups. We will have the group number 1, 2 and 4, both students didn't pass. And we have the groups 2, 6, 8, and 10, which all the students passed. This is we call a pure split, meaning that which group the outcome is the same. That's ideal. So the decision tree will choose this threshold. Study hours less than 5 is the best split. Let's start to draw. check if the study hours is less than 5. We have two outcomes. Let's check the first one. The study hours less than 5 is yes. We have the pass. It's like 0. And for study hours less than 5, and the answer is no, the pass is 1. It's positive. So you can see the entire tree is now complete. And it only needed one question. And that's the full draw of the decision tree. So let's keep going. Maybe you're asking about the attendance. Let's check about the attendance now. Start by taking my notes here. So you might wonder that if the attendance could be useful. Let's think about that. Keep drawing here. And thinking. The students with 0 attendance include 2 who passed, and the students with 1 attendance include 1 who passed, the number 8, and 2 who didn't, number 2 and 4. And we have 3 students. And we have 3 students with 1 attendance. 1 who passed, and 2 who failed. So, attendance alone doesn't clearly separate the outcomes. So, that's why the tree doesn't choose attendance as the first split, because study hours gives a cleaner decision, and the attendance, as you're checking I'm drawing now, it doesn't help. So that's why tree decision doesn't choose attendance as the first split, because study hours gives a cleaner division. And that's why the attendance wasn't chosen. And let's check more on tree structure and use cases. This is a great example of shallow tree, meaning it only has one decision point. In more complex dataset, trees can grow deeper and combine several features at different levels. One advantage of decision tree that they are very interpretable. You can explain exactly why a prediction was made, but they also have limitations. For example, they can overfit on noisy data if not prunned or regularized. Let's wrapping up all this whiteboard. To summarize, we used the decision tree to predict packs examined based on study hours and attendance. And all this data helps us to reach the algorithm found that study hours less than 5 was the best split, perfectly dividing students who passed for those who didn't. We built a simple but accurate tree based on that logic. This example shows how decision tree use logic and structure to make predictions that are easy to understand and explain. Thank you all for watching my presentation, and let's go there.